Question 8, the one that involves some kind of series expansion. Again, we've got to show that this is true. Now, this is this thing about showing that you have to be really convincing when you're showing it. So go through all the steps. We know that in order to put this together, we need to put it over a common denominator. The common denominator, because there aren't any common factors there, must be the product of those three things. So the first expression, we've multiplied top and bottom by r plus 1, r plus 2. The second expression, we've multiplied by r plus 2. And the third expression, we've multiplied by r plus 1. Put it all over a common denominator and tidy it all up, and we've got r squared plus 3r plus 2 minus 3r squared minus 6r, and then we've got, what have we got here, a plus 2r squared and a plus 2r. And at this point you can employ the James method, because you've shown enough there to be convincing, and even if you can't be bothered to check it, you could just write it's 2 minus r over r plus 1, r plus 2. That is right, isn't it? Because the r squared terms cancel out. We're left with a minus r and a plus 2. Part 2. Hence, show that this thing here is equal to that. So we've got another show that thing in here. So we've got to be convincing in getting to that answer. So we're going to write this. Well, this sum, this is the method of differences, isn't it, when we've got these fractions. What we're going to do is we're going to write out enough terms so that it'll be convincing. So we're going to start our sum. I can't remember to write it on out. Our sum is going to be sub in 1, and we get 1 over 1 minus 3 over 2 plus 2 over 3. That's what we got as 1 mark for just getting one term correct in this. But that's not going to be enough. There's 3 fractions here, so we probably need at least 3 terms until we can start to see the pattern. The next term, if you put 2 in there, will be 1 over 2 minus 3 over 3 plus 2 over 4. We then have 1 over 3 minus 3 over 4 plus 2 over 5. That's enough. I felt I wanted to be extra certain what was going on here, so I put another one in. And there's no harm in doing that. I think we've got enough of the pattern there. And we can see that they're matching up. We've got minus 3 over 2, plus a half and plus 1 there. So they would all cancel out. We've got thirds there. We've got 3 of them take away 3. We've got quarters. And we've got 3 of them take away 3. So we can see that the pattern is working down in every 3 rows. So I need to have 3 rows at the end as well. My last row is going to start with 1 over n, so it's going to be 1 over n minus 2, isn't it? 1 over n minus 2 minus 3 over n minus 1 plus 2 over n. And then I would have 1 over n minus 1 minus 3 over n plus 2 over n plus 1. And then my very last one is 1 over n minus 3 over n plus 1 plus 2 over n plus 2. And that matches up with what we started with up there. We recognise now that we've got some quite nice things going on here. We've got 1 plus a half minus 1 and a half, so those 3 cancel each other out. We've got 2 thirds plus 1 third take away 3 thirds. 2 quarters plus a quarter take away 3 quarters. And so it would keep going on as we match them up. Those 2 would cancel out. Now there's 2 that would cancel with that one. We would lose that one with the 2 that are down there, and these 2 would go out with the one that was up there. And we would also get rid of those 3. We've got 2 There's another one, it's 3 over n, take away 3 over n, leaving us with that bit down there. So altogether we're left with 2 take away 3 over n, plus 1, sorry, plus 2 over n plus 2. We've got to put that over a common denominator of n plus 1, n plus 2. And that would be, what, minus n plus 2 plus 2 lots of n plus 1. And again, you can use the James method and say, hence, we've got n, that's n, isn't it? Over n plus 1, n plus 2. Now the final bit of this, we've just got time to look at it, says, find the value of the sum from 2 to infinity of that thing there. So when you're going to think what that all means, the sum from 2 to infinity of our series, well, that's the sum from 1 to infinity of whatever our series is, take away the first term. Because we're not including the first term, we're only starting at 2. And the sum from 1 to infinity of this bit here, well, as n approaches infinity, what would happen to this expression here? We would get something very big on the top, well, we'd get something that was very big squared on the bottom. We get something that was massively bigger than the thing on the top. We've got a thing of order 1 on the top and of order 2 on the bottom. And as n gets bigger and bigger, that bottom term becomes very, very dominant. And if you've got a fraction where the bottom line is much bigger than the top line, it approaches 0. So we've got 0, take away that very first term that we had, and the first term was 1 minus 3 over 2 plus 1 over 3, was that right? 1 minus 2 over 2 plus 2 over 3, sorry, 2 over 3. And so we've ended up with 0 minus a sixth. So the sum that we were looking for, the answer we wanted was minus 1/6. There we go. And that's maths.